Oh, wait, you're listening?
Okay.
All right.
Okay.
All right.
You're
Listening
to Radiolab.
Radio
From
WNYC.
See?
Yeah.
Hey, it's Latif. This is Radiolab. I just wanted to come in at the top of this episode here quick to say that our senior correspondent, Molly Webster, is going to be hosting and reporting this episode. And not only that, she's going to be doing that for a few episodes here and there over the next couple months. And what she's going to be bringing you, well, internally, we've been calling them Molly's hot tub convos with scientists. They are not actually happening in hot tubs, but they will be more conversational than our typical episodes, a little less edited. Our irrepressibly curious Molly will be on one side, and then on the other side will be a scientist or scientists who are on the edge of something totally new, something with real human stakes, but also something that transcends us humans, revealing something deeper and richer about our entire universe. So that's it. I'll let Molly take it from here.
Håret vatra, det vitjar, säger nattsvår, spivaje. So people will start one after another, groups will start round after round, and you just keep going until the fire is lit.
And what does it mean? Like, what do the words say?
The fire is burning. This group of people are singing.
Hey, I'm Molly Webster, and I'm your host today. I want to tell you a story that involves two people on the opposite ends of the same mystery. The first person is Leda Kobziar. You just heard from her singing. She is a scientist who studies wildfires, in the remote backcountry of places like Idaho and Utah. The second person in our mystery is a doctor, Naomi Hauser, and she works at a very busy hospital in California. There's a world in which they never should have met each other. But this is a story in which opposites are standing side by side. There's big things next to small things and visible things next to invisible things. And for us, our story starts one day 4 years ago when Naomi, who is an infectious disease doctor, got a strange call.
We got a call in infection prevention that there were an unusual number of mold infections, and they were all burn patients.
So, wow, that a person can grow mold on them.
Yeah, from different places in their body. So sometimes in their blood, sometimes like in their tissue. People who have like skin injuries, like burn patients, they can actually get mold sitting on the tissue where the skin has been lost. So it might look kind of yellowish and can be kind of fluffy sometimes.
Whoa. So the patients that you got called about, did you say they were all burn patients?
They were, yeah.
How many were there?
So it doesn't sound like a lot, but it was about 6 in a month.
Okay.
Which normally you might see 1 in a month or less. And they were all different molds.
So each person had a different fungus.
Some people had more than one.
Whoa. Okay.
And it just didn't make sense because normally when you see an outbreak in a hospital, like say there's a contaminated equipment or something like that, you would see that everyone has the same infection. But this was weird because everyone had different infections.
Huh. So they come to you, they're all different molds. Like their question is the hospital infected?
Yeah, because we have to know so that we can fix it. And so we had to go through all the normal steps, like look for that moldy sink or that moldy towel that somehow fell behind something and, wasn't cleaned up or something like that. We couldn't find anything. So then we had to keep looking.
Okay.
you think about like how else can things get into this patient's room. We climbed into the ceiling to look at the air filters.
By we, do you mean I? You?
Yeah, it was me and some of the environmental services people. We got into the kind of in-between floors in the ceiling.
Wow.
To look at the air filter system to make sure that was working. And what we learned was that the air filters were getting so overwhelmed by the wildfire smoke that they were just black. And the motors were shaking.
Oh my gosh.
Which was totally unexpected because we had never really had a wildfire season that bad before.
Huh.
So then I thought, could this have something to do with it? That was 2020. I was riding my bike to work then, and I would wipe my bike seat off before I sat on it. Yeah, from ash. Yeah. I had to wear an N95 on my bike, and you would go outside and everything was yellow, kind of yellowish gray. Like
in a movie about an apocalyptic disaster.
It felt like that. It looked like that, and it felt like that. I mean, the wildfires were not in Sacramento where I live and work, but the smoke travels. So when I saw the filter, what we actually did after that was we tested the air for fungal spores inside the unit to see if they had been getting in. So far indoors, it's just as clean as we hoped.
Okay.
So could they have been carried to the patients through smoke before they came into the hospital?
Meaning like people could be exposed before they even walk in the door.
Yeah. So then that's when I thought I should start looking into this question. Is there stuff in smoke that can cause infections?
I was born to Ukrainian immigrants who immigrated after World War II. As Ukrainian-American kids, we all grew up at Ukrainian scouting camps, and we learned to survive in the woods, and we learned to use plants, how to build traps for trapping small animals, how to collect water, learn to build fires and control and use fire. You know, we'd always sing a song to make the fire light. The song is really about celebrating fire.
Can you just introduce yourself to me on tape?
I'm Leda Kobziar.
Kobziar.
That's perfect.
Okay, great.
I would call myself a fire ecologist.
Okay. Tell me, like, what a fire ecologist does day to day.
Well, I guess I would first say that it's different for every fire ecologist. Myself, I've really been interested in fire effects on plants and the soils that are the foundation for plants.
So then how did you got to studying smoke. How did that happen?
I guess I could tell you the whole origin story if you want to hear it.
Yeah.
Okay. Yeah, it was a Friday.
You know the date. Oh, I love that.
That's because I taught fire ecology every Friday. And every Friday that the weather conditions were right, we would conduct prescribed burns on our school forest at the University of Florida. So you spend a lot of time standing around the fire, just kind of looking at it, the same way you do with a campfire.
What a fun class.
Oh, it was such a fun class, yeah. I would watch the fire and I would focus on what it was doing to the plants, how quickly it was burning them, which ones were burning completely, which ones, appeared to be emitting volatile oils on their surface leaves.
I see an oil.
Exactly.
I don't know how one sees that.
Well, there are amazing plants that are, evolved to burn. They do what we call glass up. basically the volatile oils in the plants get moved to the surface of the plant, and then it combusts.
Oh my gosh. Okay, so there's lots to stare at when a burn is happening.
Yeah. And you stand downwind of the fire because that's the way that the fire is going to spread. So I was watching the smoke. It was kind of pooling under some of the slash pine trees that we were burning under, enjoying watching the saw palmetto glass up. And I started thinking about an article that my friend sent me. And that article was about how microbes, bacteria in particular, were being added to snowmaking machines. It was completely new to me. I had absolutely no idea that bacteria would help the formation of snow or clouds or anything. And then I was looking at the smoke and thinking about when smoke mixes with water vapor, it creates an incredibly, incredibly opaque fog. And I wondered if there were bacteria in it.
In smoke?
Yeah.
Meaning, if bacteria can help make snow and is in snow, could bacteria be in smoke, helping to make fog?
Exactly. And we were heading out on a prescribed burn the next week. And so we created an experiment and found a graduate student who really needed a project and had, I think, a month or two to finish her thesis. And and she worked to design a sampling mechanism that would allow us to hold up Petri dishes to the fires that we were burning on Fridays. So we suspended the Petri dishes and had teams of students at different distances from the fire and downwind in the smoke, and then another team that was upwind, so they were in conditions that weren't receiving smoke. And we took those Petri dishes and incubated them and grew whatever we could grow on them.
Did you grow stuff?
Yeah, we grew hundreds and hundreds of colonies. And
you grew hundreds and hundreds of stuff from smoke?
Yeah. And it grew fast, and it was both bacteria and fungi.
You're saying it so casually, but I had no idea. So in smoke, there's living bacteria?
There's living bacteria in smoke. Yep, absolutely. And in comparison to what we saw in the ambient air, the air that wasn't affected by smoke, it was about an order of magnitude difference.
What is an order of magnitude?
Like times 10.
There's that much more stuff floating in the smoke as just normal air?
Yes, at least.
Whoa.
Yeah. And now I know that number is probably bigger.
Wait, what do you think the number is now?
Somewhere between, 20 and 100 times as many.
There could be 100 times as much stuff in smoky air as in non-smoke. Alive stuff.
Potentially, yeah.
What was growing? What bacteria? What fungi?
A lot of different Fusarium, Cryptococcus, Oreobasidium, Alternaria, Cladosporium, Molossesia. What else have we found? Thousands at this point.
Thousands.
Yeah.
How is bacteria and fungi not devoured in the fire? And I just don't even understand how it's even still in a bacteria form, let alone still living. Because I think fire, hot,
Right.
burn, done.
And it certainly is hot, but
Thank you for that validation.
So there's a lot of variability in what's happening at every scale in a fire. There might be a little depression in the earth where the air temperature is a little bit cooler, and then nothing in that little depression burns. And, you can consider that as a type of fire refugia.
Wow. Okay.
So it's just more variable than we think.
Even though you're surrounded by hotness, you don't necessarily, as a living being, have to burn.
Exactly. You can get entire branches tops of trees or even whole trees that get swept up into the uplift of the winds that are created by the fire. There's just a tremendous amount of energy in some of these really large wildfires.
Wow.
So think about a little piece of plant material burning. So that little piece
And
of...
can we say it's like a leaf? Can we make it like a little more friendly?
Sure. It's a happy little leaf from an aspen tree.
Oh, love. Okay.
And so that little piece of leaf that's left over, just like the little pieces of wood and things that you find in your campfire at the end of the fire, that little piece of leaf gets picked up in those winds. It becomes part of the smoke column. And on that little piece of leaf, there are bacteria and fungi that live. Once the outer part of that leaf is consumed in fire, then the inner part of that leaf is now exposed.
It's like the roof on its house just got ripped off.
Yeah, exactly.
And now it can get sucked out like in Twister.
Exactly. If you think of it in the context of ecological work that fire is doing, what it's essentially doing is giving these organisms a way to get away from the fire. Maybe fire is a new kind of vector for dispersal. And I think that's what, I would wake up in the middle of the night thinking about.
And did you take your news to people? Were you like, oh my God, we developed these petri dishes that we grew all this stuff on that came out of smoke? And people thought, why didn't I do that? Or you're wrong, or I'm bored. What was the reaction of the people around you as you brought this news?
I think a lot of people thought it was kind of cool, but didn't really think about the implications.
I'm just thinking about Naomi Naomi Hauser and her work thinking about fungal infections in specifically burn patients.
Mm-hmm.
Yeah.
What ended up happening to those patients, to the 6?
3 patients died in the hospital.
From the mold, not the burns.
So the factors that most determine mortality in burn patients are age and burn size. And the larger the burn size, the higher the risk is of getting an infection, and especially a fungal or mold infection. We can't say for sure that those infections came from the wildfires, but we can say that it correlated.
Wow.
Yeah. The thing is, there are so many questions we don't have answered about wildfire smoke that I think we need to answer.
What are ones you're thinking of?
Well, I mean, what I'm really worried about is how infectious are these organisms? How many are there? And where are they going? Because I want to know. I think, for my patients and for myself, I want to know, are these infections that I should expect to see? And as we have more exposure, should we expect to see them in people we don't typically expect to see them in? Can they start showing up in healthy people because we're just covered in more of it than we were before?
So last summer, Canadian wildfires sweep into New York City, or like the smoke of the Canadian wildfires kind of settles over New York City, settles over most of the Midwest. Am I in that moment is Canadian fungus like raining down on me? Canadian bacteria? Is it landing in my garden? Am I snuffing it into my nose?
I don't know. I imagine that some of it is, but we really don't know at this point how much. I mean, I think from the very beginning, when I told people about this work, that pretty much is the first question, is what does it mean for human health? And so then, I look back at the list of fungi that we sequenced from a given smoke sample, and I see that there are 3 on the list that are human pathogens, and the connection is made. It doesn't mean that they were necessarily living or that there was enough of them to cause an infection in a person, but they're there. And, our team is one of the few that are looking into these questions, and I feel like it is our responsibility to address that question. So I'm definitely interested in that, but I'm equally interested in the role in biodiversity and basically, the biological or ecological repercussions of the spread of these organisms.
Leda and her colleagues have seen things that are scary for humans and things that are scary for animals, but they've seen way more of other things, like bacteria that love nitrogen and help trees grow, a type of fungus that helps things break down on the forest floor, like dead plants and animal bones, bacteria that keep the oceans healthy, and fungus whose cousin is used to make antibiotics, and others who love salt and heat. It's all up there, floating in the smoke.
This is just a very new and different way of looking at what smoke is. To think of smoke as essentially, having life in it or being alive in a way, I think really changes the way that we think about the perimeter of a fire. It is no longer just affecting the life within it. It's also potentially transporting life across long distances.
This episode was reported by me, Molly Webster. It was produced by Sindhu Nanasambandhan and edited by Pat Walters. There was production help by me and Timmy Broderick, our once and former intern. Thank you so much to Leda Kobziar and Naomi Hauser. I did want to give a shout out to Leda's original research when she first started sticking Petri dishes near the flaming front. That work was inspired by a paper by a father-daughter team that was originally for a high school science project. You can find that paper on our website, or you can just Google MIMS and microbes, and your eyes will be further opened. If you like hearing about fungus, things that could be in the world that can get inside our body, then you should go check out another episode I did for Radiolab called Fungus Among Us. If you don't like listening to those things, then maybe don't go check it out. And lastly, we've got a newsletter. It's always been fun. It's getting more fun. You should go sign up for it. Go to radiolab.org/newsletter, and it'll land in your inbox soon. Okay, thanks so much for listening, and see you later.
Hi, I'm Emma, and I live in Portland, Maine. Here are the staff credits. Radiolab was created by Jad Abumrad and is edited by Soren Wheeler. Lulu Miller and Latif Nasser are our co-hosts. Dylan Keefe is our director of sound design. Our staff includes Simon Adler, Jeremy Bloom, Becca Bressler, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Nanasambandhan, Matt Kielty, Annie McEwen, Alex Neeson, Valentina Powers, Sarah Kari, Sarah Sandbach, Ariane Wack, Pat Walters, and Molly Webster. Our fact checkers are Diane Kelly, Emily Krieger, and Natalie Middleton.
Hi, this is Ellie from Cleveland, Ohio. Leadership support for Radiolab science programming is provided by the Gordon and Betty Moore Foundation, Science Sandbox, a Simons Foundation initiative, and the John Templeton Foundation. Foundational support for Radiolab was provided by the Alfred P. Sloan Foundation.